Our first speaker today will be Graham McKinnon, who is the founder of Norcada, which is a small silicon-based MEMS micromachine design and development company based in Edmonton. Graham's been active in Alberta's microelectronics scene for many, many years, for more than 20 years. He led the development of silicon micromachining technology at AMC, Alberta Microelectronics Centre, and was instrumental in the foundation of Microline. So without any further ado, I'm going to hand you over to Graham.
How does this work? I'll put this in the carpet.
I'll put that on your lapel.
And that should work. And Kevin, how do I work this guy?
I guess the arrows are pretty obvious.
Yeah, okay. We'll just go. Okay, good. Good morning. So as Kevin said, I'm founded a small company called Norcada, along with my partner, Yuban Ning. I've been active in this whole area of microfabrication or micromachining for over 20 years, and I'm just going to give a little bit of an introduction to it here. So essentially, what do we mean by microfabrication? Historically, it referred to the whole semiconductor industry and the semiconductor process of making integrated circuits, where we are able to build up multiple layers of dielectrics, insulators, semiconducting materials, metals, to form our electronic circuitry. And up there, just a sort of a view of a circuit and a cross-section showing all these stacked layers. There's actually a lot of physical structure to these. So what happens now is we've had advances in this whole area of micromachining, or micro-electromechanical systems, MEMS as they're sometimes referred to, where we're taking these same processes that we used in the semiconductor industry to build physical structures. And just as an introduction to this, looking at the semiconductor circuit on the left, if you actually removed the dielectric layers from it, you would have physical structures of posts and beams and that type of a thing. So this is what we're doing in this whole area of microfabrication. So essentially microfabrication, first of all, we started off with the field of microelectronics, but are now introducing to it micromachining, microfluidics, microcircuits, where we're working with our metallization technologies, microassembly. This would include things like through silicon vias, stacked wafer technologies. So I'm going to focus a little bit on the micromachining component of this, where we are building small physical structures that can either be actuated or act as sensors for different applications. So typical examples that you see in micromachining these days are inkjet printers, different types of sensors such as pressure sensors, accelerometers, microphones, optical switches. Just to give an idea of scale here, this is a device that we had built, a small relay switch. We're 1/10 of a millimeter across there. So you see beam sizes on the order of microns. So what we've got with this microtechnology, we had a lot of talks this morning about nanotechnology. With nanotechnology, you're actually engineering or structuring the materials themselves. With this microfabrication technology, we're working with the materials and forming them into shapes. Rather than structuring the material, we're structuring devices out of it. So micro and nano are very complementary. Sometimes it's a gray area between the two, but it refers to more than just the dimensional scale, because with microfabrication we can certainly get down into the nano regime in terms of size. So just some examples of what you can make with this microfabrication, micromachining technology. I'm not going to go into the processing methods of how to do it. That's a whole different talk. But I just wanted to give a brief introduction into the sort of structures that we can do as we miniaturize shapes and devices. So certainly beams, girders, posts, that type of a thing, physical structures we can do. Gears, there's been a lot of work done on small miniature motors. Springs. What happens with this is we have to work with the compliance of the material itself in order to form these structures. So the amount of bending that we work with is what we do to make them to be able to move, because we don't have the same ability to make axles and things like that. so we can make small springs, for example, in a resonator. Torsion bars is another way to get motion out of these small structures. And hinges can be made, although they get quite complex. This is an example from Sandia National Labs in the States of a small hinge structure where they're able to lift a device out of plane. And of course, this also includes microfluidics, or miniature plumbing systems, where we can use etch channels, putting tops on them to significantly reduce volumes of fluids that are needed, both in the reagents, the samples you want to work with.